Welcome to this explainer. Today, we're taking on a topic that honestly feels like absolute magic every single time you step foot in an airport. But as our source material from Professor Wingit brilliantly points out, it's not magic at all. It's entirely grounded in physics. We're going to break down the actual mechanics of flight using Professor Wingit's guide to the skies. So if you've ever looked out of a plane window and wondered how on earth you're actually up there, you are definitely in the right place.
It all really comes down to this one central, kind of paradoxical question. How does a giant metal bird, a machine that literally weighs thousands of tons, stay up in the sky without just falling straight out of it? I mean, when you really stop and think about it, a commercial airliner looks like it has absolutely no business being in the air. But, as Professor Wingit shows us, we can completely demystify this whole thing just by looking at a few fundamental physical laws.
Okay, let's dive into this. Here is our agenda for today. Number 1, the 4 forces of flight. Number 2, the secret of lift. Number 3, angle of attack. Number 4, how jet engines work. And 5, ready for takeoff. Section 1, 4 forces of flight, the ultimate tug of war.
Flight is basically this epic, 4-way battle taking place right up there in the sky. Imagine an airplane cruising along, right? It's actively being pulled in 4 completely different directions. First up, you have weight. That's gravity pulling the plane straight down to the ground, heavy as an anvil. Fighting directly against that is lift. That's the air pushing the plane straight up, almost like a giant balloon lifting it into the clouds. Then we have thrust, which is the forward motion, pushing the plane ahead, kind of like a tiny rocket taped to the tail. And finally, fighting against that thrust is drag. That's the air resistance pulling the plane backward, just like someone trying to hold the plane back with a massive rope. The thing is, cruising smoothly through the air isn't about eliminating these forces, it's about perfectly balancing them. To stay up in the sky, your lift simply has to beat your weight. And to keep moving forward, your thrust absolutely must beat your drag. So that begs the question, if lift has to beat the anvil-like weight of gravity, where exactly does all that upward force come from?
Section 2, the secret of lift, defeating gravity.
Let's zoom right in on the wing itself, or what we call the airfoil in the aviation world. We actually need to start by aggressively debunking a super common misunderstanding here. The myth is that 2 air molecules, let's call them speedy and slowpoke, split at the very front of the wing and absolutely must meet up at the back of the wing at the exact same time. You might have even been taught this in school. Well, we're putting a giant red myth stamp right over that. It is simply not true. The reality is that the wing is specifically shaped to curve the air downward, and it's this action, curving the air, that creates massive pressure differences, which fundamentally causes the air to push the wing up.
So let's break down the 2 physical rules that make that reality happen. First up is Bernoulli's Principle. Because of how the top of the wing is curved, the air moving over the top actually moves much faster. So the crucial point is this: when air moves faster, it creates a zone of lower air pressure right above the wing. Think of it as a sort of invisible bubble of low pressure sitting right on top of the wing, which essentially allows the higher pressure underneath to help push the entire plane upward.
But here's the thing, Bernoulli is only half the story. The other half? Sir Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. When the bottom of the airplane wing hits the oncoming air, it physically deflects that air downward. Pushing the air down is the action. The equal and opposite reaction? The air pushes the wing and the entire heavy metal bird attached to it straight up. You combine Newton with Bernoulli, and boom, you have defeated gravity. Now we know how the shape of the wing works, but how does a pilot actually control it mid-flight?
Section 3, angle of attack, tilting the wing.
Now, angle of attack sounds highly technical, right? But honestly, as Professor Wingit points out, it is really just a fancy term for tilting the wing. By tilting the nose of the plane up, the pilot tilts the wing upward into the oncoming wind. Doing this catches way more air and forces more of it downward. And thanks to our friend Newton, pushing more air down means you get a lot more lift pushing you up. It's an incredibly effective way for pilots to control their altitude. But there is a catch. They can't get too greedy with this tilt.
Yeah, if a pilot gets too greedy and tilts the nose up way too high, we get a flashing yellow warning light. Stall. When the wing tilts too much, those nice smooth lines of air that usually hug the wing suddenly break apart. The air gets messy. It turns into these chaotic scribbles or vortices. And when that air stops hugging the wing, you instantly lose that precious lift. The plane stops acting like a bird and starts acting a whole lot more like a falling rock. So controlling the angle of attack is really all about finding that perfect aerodynamic sweet spot without going over the edge.
Section 4, how jet engines work,
the powerhouse.
Okay, to get all this magical lift we've been talking about, the plane desperately needs forward speed. It needs thrust. And a complex jet engine generates this through 4 highly memorable steps: suck, squeeze, bang, and blow. Let's walk through it. Step 1 is intake, the suck. A giant fan at the front of the engine pulls massive amounts of air inside. Step 2 is compression, the squeeze. All that air is forced into a much smaller, tighter space, building up immense pressure. Step 3 is combustion, the bang. Jet fuel's added to this highly pressurized air and ignited, creating a massive but controlled explosion. And finally, step 4 is exhaust, the blow. All those incredibly hot, expanding gases blast right out the back of the engine. That massive blast out the back pushes the plane forward with incredible force, giving us the exact speed we need for the wings to do their job. So we've got our thrust from the engines, our lift from the clever shape and tilt of the wings, and we are actively managing our weight and drag.
Section 5. Ready for takeoff? Your turn.
We've put all the building blocks together here. Planes do not fly by magic. They fly by balancing forces and utilizing physics to catch the wind. So, I'm going to leave you with this question. Next time you are looking out the window at 30,000 feet, are you just going to see magic, or will you see the perfect continuous balance of lift, weight, thrust, and drag working together to keep you safely in the clouds? The next time you're at the airport, look at those wings, listen to those engines spool up, and know that you completely understand the science keeping it all up in the air. Happy flying, and keep seeking out